By now, you ought to be very familiar with what an easy differentiation scenario looks like. Meaning, if you had, for example, y is equal to 2x squared, this is an example of a very easy to differentiate scenario. It's just going to become 4x when you do dy dx equals to 4x like this. The reason why it's easy, make sure you understand it's going to be if you have a number times x power of another number. As long as it's anything in the format of a number with an x power of a number, this is an example of the easy to differentiate format. You can do it pretty much straight away. So when you're looking at these ones right now, this tutorial, the purpose of this is really make sure you know what to do. If you're given something to, you know for a fact you have to differentiate, make sure you know what to do over there so that it can happen. Point is this, when you look at example 1, okay? What we're focusing right now is we're trying to focus on how we do dy dx for each of these scenarios. When you look at example 1, what you really think about over here is without needing to be told, you realize this is not the acceptable format for differentiation yet. As in the easy example we talked about before, the easy format, which is a number times x power of another number. Objective over here is this needs to look like the easy format first. As in, it has to look a certain way before you can do the differentiation principle, right? Applying just the power times the number in front, right? Number times x power of a number, you understand it's going to be this number times this and this number minus 1 for the differentiation scenario. So when you look at question 1 over here, you'd realize step 1, this needs to be rewritten, and when you rewrite this, you'd realize the objective over here is to make x the power of a number. If you have square root of x, it's the same thing as to the power of a half. Type in your calculator, square root of 9, square root of 25, square root of 16. Understand every single one examples we said just now, 25, 16, and 9 to the power of a half, you get the same answers as the square roots. So your first step would be y is equal to 2x power of a half. So when you're doing this tutorial later, if you're watching this, you pause the video, see if you can write the differentiation here. So question 1, see if you can write the differentiation for this. If you can't, then you just write down dy dx equals to. Play the quick video and see if you follow this. So the point is, pause it, see if you get question 1 correctly. If you don't get it, play it, and make sure you get how it's going to be dy dx equals to. You make this equal to 2x power of a half first, and then do a half times 2, which is x, half minus 1, negative half. A half times 2 is obviously just 1. So you understand this is going to be x to the power of negative a half for the differentiation of this. Number 2, you realize, hey, this is not the acceptable format yet. The acceptable format is an easy version, which is a number times x to the power of another number. You realize, hey, isn't this going to be the same thing as 12 times 1 over x, which is the same thing as 12 x power negative 1. See how y is rewritten into this first, 12x power negative 1. Advantage over here, you can tell it's just going to be, this is very easy to integrate, differentiate now, excuse me. Negative 1 times 12, negative 12, x to the power of negative 1 minus 1, which is negative 2. Question 3, pause it, right? You know the drill here. See if you can do the question correctly. If you don't, play it to this. Make sure you understand how this is going to be if you were to differentiate this. Anything to the power of 2 and cube roots is the same thing as, so check this out. Make sure you understand this principle over here. This is from IG Basics. If you have x power of a over b, it's the same thing as x to the power of a with a b root like this. So what I mean is type in your calculator this, okay? Type in 7 to the power of 4 over 3. Press equals and see if it gives you the same answer as 7 to the power of 4 cube root like this. You'll find it's going to give you the same answer. 10 to the power of 2/3 is the same thing as 10 to the power of 2 cube root like this. 10 to the power of 69 over 420, same rule as 10 to the power of 69, and then 420 of root over here like that. So you understand how this thing is the same thing as what? X to the power of 2 over 3 like this. Why would you think to do this? Because this is going to be the easy to differentiate format, all right? See how you'd have to recognize it's going to be this first, and then differentiating that is going to be 2/3 x to the power of 2/3 minus 1, which is going to be negative a third, just like that. Same thing over here. This is not the acceptable format, right? It has to be a number times x power of another number, which is anything divided by a half is the same thing as 0.5 times x power of 6 over here. Make sure you're not confused about how it becomes that, and it's just going to be 6 times 0.5, 3x to the power of 5, just like that. Number 5, recognize that anything fraction just means divides, isn't the same thing as 4 to the power of 1 divided by x to the power of a half. See how that works? Check this out. Remember, if you're confused about this, think about how if you did x to the power of 2 divided by x to the power of 1, isn't that the same thing as x to the power of 2 minus 1? Just like if you did x to the power of 69 divided by x to the power of 5, isn't that going to be equal to x to the power of 69 minus 5? You get the basic principle over here. So if you did x to the power of 69 over x to the power of 5, is there any reason why it wouldn't be the same thing as x to the power of 69 minus 5 also? Because it means this divided by this, right? So over here you'd recognize, hey, it's going to be the same thing as 4x divided by x to the power of a half, which is there's a 1 over there, which is the same thing as individually x to the power of 1 divided by x to the power of a half, which is going to be equal to 4x to the power of 1 minus a half, which is this. And now you've transformed this into an acceptable format for differentiation, as in you turn this fucked up looking expression into the easy to differentiate format, which without further ado, you'd realize f dash of x differentiation is going to be a half times 4, 2x to the power of a half minus 1, negative a half, just like that. Number 6, see if you got this answer. See the problem over here? You can just tell at first glance, right? This is not the acceptable format for differentiation just yet. You need to turn it into the acceptable format, and then step by step, you'd realize, hey, isn't this the same thing as a 1 over there? Isn't that the same thing as the power of a half over there? Which you can combine these powers here, can't you? First step is 2x power 1 times x power of a half. Just focus on one step at a time. Write some extra lines of working, but if you have the correct working, it doesn't matter if you took an extra 1 or 2 lines. You know you're going to guarantee to have the correct answer. So 2 to the power of 1 times x power of a half is just going to be like that, yes? 1 plus a half gives you 2x to the power of 1 plus a half, could be 1.5 like that, divided by 3x to the power of 3, and then you'd understand, make sure you understand the algebra rule over here. It's the same thing as what? 2/3, you can put an x in the middle over there, can't you? Because 2 over 3 is just 2/3, and you can put the x over here like that in the middle, which is 1.5 minus 3, because 1.5, x power of 1.5 divided by x power of 3 is 1.5 minus 3, which is negative 1.5. You now have turned this fucked up looking expression into an easy to differentiate format. You know what it looks like now, the easy to differentiate scenario, this times this. If you don't know what that is, just type in your calculator, 2/3 times negative 1.5. You'll find it's going to be negative 1, so it's going to be negative x to the power of negative 1.5 minus 1, which is negative 2.5, just like that. Number 7, you realize, hey, this is definitely not the easy to differentiate format, is it? Would you need to be told to expand this to turn it into y is equal to x squared plus 5x minus 20 minus 4x? There's a lot of ways you can do this, right? But make sure you understand how it just overall becomes x squared plus x minus 20 like that, and then you can differentiate individually these components. No confusions. So dy dx is going to be equal to 2x plus 1, just like that. This obviously has no relationship of x when you differentiate it, right? It's just going to be 0, so it's going to be 2 times x, 2x, and plus x is going to be differentiated into 1. Make sure you understand how, I'm sure you understand how plus x differentiates into plus 1. Number 8, here's the very common type of scenario you'll see in the exams. You have like a question, y is equal to this, and you need to differentiate that. Dy dx equals a question mark. Now, of course you could do it this way. You could realize the same thing as doing this, and then individually expand it out to get 2x squared times this minus 3 times this. Expand it out long way, group it, simplify, and then differentiate individually, right? But an easy way to do this, remember, as long as, so here's an example of the special rule. This comes up a lot. As long as you have a bracket, a single bracket, is this a single bracket? Yes. As long as the single bracket contains something involving x, and it's to the power of a number, doesn't matter if there's a number in front, as long as you have a number in front times a component, a bracket, a single bracket involving x to the power of another number. So if you had a 4 over here, that also works. We'll look at a lot of examples like this. But just for this one over here, all you got to do is recognize it's a special scenario. Special scenario is just as long as you have a single bracket involving x to the power of a number. Is this the case? Yes. Special case? Yes. If it's a special case, you just apply the rule where pretend this is a regular x. If we had y is equal to x squared, what would that become? You know, if I don't need to be told, you can do this in your sleep now. Y is equal to x squared is going to become 2x. So you just pretend that's a regular x. 2 steps. 2 steps, okay? You just pretend this is a regular x, so it's going to be 2 times whatever that is. No problem, that's applying the first step. If you pretend that's regular x, x squared becomes 2 times x, which is 2x. So if this is regular x becomes 2 times this, which is 2 times this, that's your first step. And you just have to include one more step, which is, so 2-step process. Put a 2 in front of there, because if this were a regular x, you treat it like that, wouldn't you? X squared becomes 2x. So you put the 2 in front over there. It's going to be 2 bracket 2x squared minus 3. 2 minus 1 is just 1 over there, so you don't need to write the 1, because anything to the power of 1 doesn't change the answer. One extra step, which is times the whole thing. Notice how putting a bracket over there means timesing this entire thing by the brackets. So your first step, 2 bracket 2x squared minus 3, times the whole thing by the differentiation inside there, which is 4x. And then you can tell this can be simplified, isn't it? Because this just means this times this times this, which means you can do 2 times 4x first, can't you, to simplify it, which is 8x bracket 2x squared minus 3. You could expand that if you wanted to, 16x cubed minus 24x. This is the differentiation of this now. Dy dx equals to that. Number 9, look at this. Not the easy to do format, is it? See, this is very repetitive by now. You should have recognized that, hey, when you're doing these questions, if they don't look like the easy to differentiate format, all you got to do is make it into the easy to differentiate format. Easy to differentiate format, remember, is going to be a number times x to the power of another number. Over here, you could simplify that, couldn't you? You realize this is the relationship with what? Check this out. If you don't get this, remember the basic rule. Imagine T represents how much money this person makes a day. Could be the amount of number of thousands of dollars Timothy makes in his business every day, plus the amount of money that maybe this person makes. If we divide that by 2, do we agree that algebraically t plus d divided by 2 is the same thing as t over 2 plus d over 2? Yes or no? Do we recognize this basic relationship? Are you confused about that? If you have 10 plus 50 divided by 2, isn't that the same thing as a half of 10 plus a half of 50? This is the rule that we're relying on over here, because if you understand this rule, doesn't that just mean, see the similarities that we can draw over here? The parallels here are going to be 2x over x squared minus 5 over x squared, which we recognize as, oh, this is just going to be x like this, 2 over x. 2 over x is just the same thing as what? 2 over x is the same thing as 2 times 1 over x, which is the same thing as 2x to the power negative 1. What's the guiding principle over here? We're trying to make this into the easy to differentiate format. Minus 5 over x squared is the same thing as, these are the algebra things that you might be weak on. If you can't do this, it means your algebra is lacking. So minus 5 over x squared isn't the same thing as negative 5 times x power negative 2. Think about it. Minus 5 over x squared. Isn't that the same thing as negative 5 times 1 over x squared? Remember, 1 divided by anything to the power of x. X to the power of 2 is just the exact same thing as x to the power of 2, just put a negative in front of the 2. Right? So negative 5 times this is just negative 5 of this. So remember, when you're doing these questions over here, you're supposed to, in one take, Move on only when you can write this entire thing correctly beginning to end. That's what you're supposed to do. Otherwise, you're not really practicing this, are you? This is going to be 2x divided by x squared, which is equal to 2 over x, which is equal to 2x power negative 1. Minus 5 over this is the same thing as 5 minus 5x power negative 2. And then you can differentiate dy dx equals to negative 2x negative 2, positive 10x negative 3. That is the differentiation for this. Number 10, same principle over here. Actually, it's exact same question. Skip that. Number 11, same relationship, isn't it? We can, this one's easy to differentiate. This becomes free. This one we rewrite into 5x negative 1, which we differentiate into negative 5x negative 2. And this thing over here, we realize we need to rewrite. Isn't that the same thing as 1 over 2x power of a half like this? Which is the same thing as negative 1 over 2 times 1 over x power of a half like this. Which is, oh, it's just negative 0.5x to the power of negative a half, isn't it? Because anything 1 divided by is the exact same thing as positive version. Just put a negative in front of that. Why? Because this, why do we care? Why did we think to do it this way? Because this is what it looks like for the easy to differentiate scenario. That's the guiding principle up here. We're trying to objectively turn this into what? Something that helps us easier to differentiate. Negative a half times negative a half, positive a quarter, x to the power negative half minus 1, negative 3 over 2. Just like this question over here, we know the rule. It's going to be 4x to the power of a half divided by x to the power of a half like this. Excuse me, 4x to the power of 2 divided by x to the power of a half plus 3x divided by x to the power of a half. You can see where we're going with this. 2 divided by x to the power of a half, which we've written into 4x 2 minus a half, 1.5, plus 3x, that's a 1 over there, 1 minus a half. See why we're doing this? We're trying to get this into an easy to differentiate format, like this. And this, once we've rewritten this, because this is the exact same thing we're being represented over here. We've got the easy to differentiate version of this. You see how this works? Like we took this fucked up looking thing and turned it into this thing now, which is very easy to differentiate. Because 1.5 times 4, 6x to the power of 1.5 minus 1, to the power of 0.5. 0.5 times 3 plus 1.5x to the power of 0.5 minus 1, negative 0.5. Negative a half times 2 plus, it's plus 1, isn't it? Plus x to the power of negative a half minus 1, negative 3 over 2. This is the differentiation for this. Same rule over here. Oh, differentiation is just going to be, pretend this is the, remember this is the example of the special case. Pretend this is regular x. So if it's regular x, x power 6 becomes 6x to the power of 5. So it's going to be 6 bracket x plus 4 to the power of 5. No issues there. And then you just include one extra step, which is times the whole thing by the differentiation inside the bracket. Oh, which is just 1, which we don't need to include because it doesn't change the answer, does it? So therefore, differentiation of this is 6 bracket x plus 4 to the power of 5. Same thing over here. Oh, it's just going to be 5 bracket 3 minus 4x to the power of 4, because you recognize this is the special case. Include one extra step, which is times the whole thing by the differentiation inside negative 4. Negative 20 bracket 3 minus 4x to the power of 4 is the differentiation for this. You can guess what this becomes. Tell me the first step. It is, did you recognize it's 9 bracket x half x plus 1 to the power of 8 times the whole thing by half, which you can evaluate. You don't need to be told it can be simplified into 4.5 brackets half x plus 1 to the power of 8, just like that. Hopefully you know much better now what to do in these types of scenarios. If you look at number 16, same principle over here. Oh, hang on a minute. Why wouldn't we just put a quarter in front of that first? That's more preferable. We know algebraically that's allowed. If you don't get this relationship, that's very concerning. Divided by 4 as in you understand why it's the same thing as a quarter times the whole thing. And you can tell this definitely helps, doesn't it? Because we now turn into a clear number times something involving x to the power of another number, aka the easy to differentiate formats. When you've rewritten this into a quarter bracket 5x minus 2 to the power of 8, isn't this going to be, this is a special case, isn't it? You only got one component, one bracket involving x to the power of a number. 8 times a quarter. Imagine if this were a quarter x to the power of 8. It's just 8 times a quarter, isn't it? Times x to the power of 8 minus 1. So it's 8 times a quarter, which is 2. Because 8 times a quarter, 8 divided by 4, right? So 5x minus 2 to the power of 7. And include the extra step, which is times the thing by the differentiation side, which is 5. Which you can tell this is simplified into a 10 bracket. Because the 2 and 5 can be simplified together, can't they? Just like that. This is the differentiation of this. Okay? Differentiation of this. This is just going to be 5 times 5, 25, bracket 2x minus 1 to the power of 4 times the whole thing by 2. So I'm going to speed for a lot of these now because you should be familiar with exactly when to tell if it is the special case. And if it's a special case, you include 2 steps. Basically, the first step is something you already know, which is treated like a basic differentiation example. But you include one extra step at the end, which is times the whole thing by the derivative, the differentiation inside the brackets. In this case, which is 2. 2 times 25, right? 50. Becomes 8 bracket 4 minus 7x to the power of 3. Times the whole thing by negative 7, which, oh, it's just going to be negative 56 bracket 4 minus 7x to the power of 3. 7 times 1 over 5, 1.2 bracket 3x minus 1 to the power of 6 times the whole thing by 3. Ah, 3.6 bracket 3x minus 1 to the power of 6. special rule. If you have any questions, ask at the end, but we're going to complete this tutorial right now. This is going to be the same thing as 5 bracket x squared plus 3 to the power of 4, no confusions, as in this is the special case, times the whole thing by the differentiation side, which is 2x, which you can tell is simplified into 10x bracket x squared plus 3 to the power of 4. Over here, 8 bracket to the power of 7 now, isn't it? As in pretend it's the regular x over here, but you must include, what, one extra step at the end, which is times by the differentiation side of the bracket, negative 2x, negative 16x bracket 2 minus x squared to the power of 7. Over here, just becomes 5 bracket whatever that is to the power of 4. Copy that in. But you must times the whole thing by what? Differentiation inside of there, which is 2x. This has to be rewritten before it can differentiate it. Minus 5x to the power of negative 1 plus 5x to the power of negative 2. This is what you put inside the second bracket. 2x plus 5x to the power of negative 2. That's the differentiation of this. 1 divided by x plus 2, fucked up format. How do you turn it into an acceptable format that allows these to differentiate? Well, you want something easy component to the power of a number, isn't it? Which you realize same thing as x plus 2 to the power of negative 1. Because 1 divided by just means anything to the power of negative 1, isn't it? Oh, this is the easy case now, isn't it? This is just special case. Negative bracket x plus 2 to the power of negative 2 times the plane going 1, which is the same thing as negative bracket x plus 2 to the power of negative 2. Same thing over here. Oh, isn't that the same thing as 3 times 1 over x minus 5? Which is the same thing as 3 brackets x minus 5 to the power of negative 1. Hey, isn't this the special case we can apply now? Negative 3 bracket x plus x minus 5, excuse me, power of negative 2. Times the whole thing by 1, but we don't need to put that. Over here, 8 bracket 3 minus 2x power of negative 1. So make sure when you're doing these, right, you're only moving on when you can actually write this whole thing beginning to end, unassisted, without the solution in front of you. That's what you're really practicing over here, to know the rules. Negative 1 times 8, negative 8 bracket 3 minus 2x to the power of negative 2 times the whole thing by negative 2. This is going to be 16 bracket 3 minus 2x to the power of negative 2. Over here, isn't that the same thing as 16 bracket x squared plus 2 to the power of negative 1? Negative 1 times 16, negative 16 bracket x squared plus 2 to the power of negative 2 bracket 2x, which is equal to negative 32x bracket x squared plus 2 to the power of negative 2. Basic algebra so far, confirm. This thing over here, 4 brackets 1 over 3x plus 1 to the power of 6, which is the same thing as 4 times 3x plus 1 to the power of negative 6, isn't it? Remember, to the power of negative 6 is the exact same thing as to the power of 6, it's just 1 divided by. So if you have 1 divided by that to the power of 6, it's not just to the power of negative 6, which you know is preferable because now it turns into the number times x to the power of another number formats. Negative 24 bracket 3x plus 1 to the power of negative 7 times the whole thing by 3, which is equal to negative 72 bracket 3x plus 1 to the power of negative 6. Oh, excuse me, negative 7 for this question here. This one over here, it's just going to be 3 over 2 bracket 3x plus 1 to the power of negative 5. Hopefully you understand how this translates into this now. If you're not too sure, think about it this way. It's the same thing as this, isn't it? Algebra, which is the same thing as 3 over 2 bracket 3x plus 1 to the power of negative 5. And you've identified this the simple scenario now, isn't it, for this special case? Bracket to the power of number, negative 5 times this, negative 15 over 2 bracket 3x plus 1 to the power of negative 6 times by 3. Which, you see where we're going with this now. These rules ought to be very repetitive to you by now. You're very ingrained with them. This one over here, isn't that the same thing as 7 bracket 2x squared minus 5x to the power of negative 7? Which differentiated becomes, negative 49 bracket 2x squared minus 5x to the power of negative 8 times the whole thing by differentiation inside of there, which is 4x minus 5. Anything square root is just the power of a half, so that's going to be 2 brackets 3x plus 1 to the power of a half. And you know why we do that? Because, well, we think of that because this is the easy to differentiate format, which needs to happen before we differentiate, right? Which becomes a half times 2, bracket 3x plus 1 to the power of negative a half times it by 3, which we know is much more preferable to write as 3 bracket 3x plus 1 to the power of negative a half. Just like this one is going to be 2x squared minus 1 to the power of a half. It's going to be a half bracket 2x squared minus 1 to the power of negative a half times the whole thing by the derivative inside, which is 4x. Which we can simplify into 4x times a half, 2x bracket 2x squared minus 1 to the power of negative a half. Over here, anything cube root is just the same thing as to the power of a third, isn't it? Which is going to be, special case scenario now. A third bracket 5 minus 2x to the power of negative 2 over 3 times the whole thing by negative 2, which is going to be, that's just going to be negative 2 thirds then, isn't it? Negative 2 times a third can be evaluated together to simplify. And you can see how it becomes this. Confirm you have this answer. Move on. Number 33. Isn't that just going to be 2x minus 5 to the power of a half like this, 1 divided by, which is the same thing as 2x minus 5 to the power of negative a half. So differentiate is going to be negative a half bracket 2x minus 5 to the power of negative 3 over 2 times the whole thing by 2. Differentiation inside, which is, negative bracket 2x minus 5 to the power of negative 3 over 2. This is going to be the same thing as 6 times by 1 over cube root. Isn't that just going to be the same thing as 6 times 1 divided by the bottom stuff over here to the power of a third, which is the same thing as 6 bracket 2 minus 3x to the power of negative a third. And that's easy to differentiate now. 6 times negative a third is negative 2 bracket 2 minus 3x to the power of negative 4 over 3 times that whole thing by negative 3, which is 6 bracket 2 minus 3x to the power of negative 4 over 3. This thing over here, isn't that the same thing as x squared minus 10x plus 26 to the power of a half, which differentiated is, a half bracket, whatever that is, to the power of negative a half, times by the differentiation side of there, which is 2x minus 10. Confirmed, you get this by now. Number 36. This could be a typical exam scenario. Well, isn't that the same thing as, we could in theory do this shit, right? Plus 2. Oh, fuck, what a mission, right? No. Isn't this this is a special case now, isn't it? It's just the same thing as doing 2 bracket x to the power of a half minus 1 to the power of 3 plus 2. And this individual component, hey, isn't that just a special case? 2 times 3, 6 bracket x to the power of a half minus 1 to the power of 2 times the whole thing by a half x to the power of negative half. Just like that. Differentiation of this. Same thing over here. Hey, we realize, this is fucked up. Let's change it into a non-fucked up format first before we differentiate. It's just going to be 2x over x squared minus 3x to the power of a half divided by x squared, which is 2x to the power of this a 1 divided by x squared. It's just x to the power of negative 1. It's still going to be minus 3x to the power of a half minus 2, right? Negative 1.5. And then you can differentiate f dash of x is equal to negative 1 times 2, negative 2x to the power of negative 1 minus 1, negative 2. This is going to be positive 4.5 x to the power of negative 2.5. I'm sure you understand that. This thing over here, hey, 5x negative 2 minus 1.5x negative 5. Or 3 over 2 times x to the power of negative 5. Which differentiator becomes equal to negative 10x negative 3 plus 5 times 1.5, 7.5x to the power of negative 6. Equals to 15 bracket 2x plus 1 to the power of negative a third, which is negative 5 bracket 2x plus 1 to the power of negative 4 over 3 times it by 2, which is going to be negative 10 bracket 2x plus 1 to the power of negative 4 thirds.